We've seen CSIs on TV using this technology to catch the bad guys, but real-life cops find it just as useful. Hi, I'm Rebecca Brayton, and welcome to WatchMojo.com. And today we're speaking with firearms specialist Andy Boyle to learn more about the Integrated Ballistics Identification System. So why don't we start by having you tell us, what is IBIS?
What it is a machine that's used to photograph the markings on bullets and cartridge cases after they've been fired through a gun. They actually end up with a unique pattern of scratches on them, striations that will repeat from firearm to firearm, but are always unique.
How does the system affect investigations today?
Traditionally, it's the detectives that actually come back to the firearms examiner and say, there was a shooting last night, it seems like it was this guy who did it, we got his gun, is this the gun that did it? They might not get a match off of that crime scene, but now both those pieces of evidence are in the system. It won't forget, and any amount of time later, it might come up with a hit, and the firearms examiner can call the detective up and say, remember that crime scene from 2 months ago that we didn't have anything for you? The gun was just used again in a bank robbery last night.
Would you be able to show us some of the defining characteristics of a bullet in a casing?
Yeah, absolutely.
So your cartridge has got four main components. You got your bullet, the cartridge case itself, the primer on the back, and gunpowder on the inside. During the firing sequence, what happens is the firing pin of the firearm strikes the primer, which causes a spark inside. The spark makes the powder burn, which builds a pressure and causes the bullet to go down the barrel. The rifling marks inside the barrel that cause the bullet to twist are actually dragged across the surface of the bullet. And so you get these channels, these grooves basically, that have a unique pattern of stria all the way around. All that pressure that pushed the bullet down the barrel, equal and opposite reaction pushes that cartridge case straight into the breech wall. And so whatever pattern is on that wall got stamped across the surface of the cartridge case. And those are two areas there, on the bullet as well as on the cartridge case, that are giving you a unique pattern that will reproduce from shot to shot. The machine we're looking at here is called Bullet Tracks. It's used to do a 3D topographical scan of the markings on the bullet's surface. We mount the bullet underneath the sensor, and it'll be rotated 360 degrees around while the actual sensor is capturing the surface topography. As that light shines across, you can even still make out that striated pattern. It's doing an in-depth scan right now. So now with the acquisition completed over here, what we'll do is a cartridge case acquisition on the Brass Tracks machine. So the machine we're looking at here is called Brass Tracks, and it's used to photograph the markings on the head of the cartridge case. We're going to take photographs of the breech face marks on the primer. We're going to do a close-up of the firing pin impression as well, and we're also going to do a close-up of the ejector mark on the side. On this cartridge case, you've got the silver disc on the back of it. We're going to do some photographs of that silver disc, the primer, so we'll do that right now. What it's going to do now is what we call the full head stamp. It's going to take a series of 9 photographs, which it will then reconstruct into one giant image that's got the entire head of the cartridge case in one giant photo. So what we're looking at now is a close-up of the breech face information. All the striations that were marked on that breech face that was photographed, we're able to look at them side by side and move the hairline back and forth to see how much is common between the reference exhibit and the test one. Here's your reference. This is a guy that was the standard during the correlation, and this is a guy that was in the database that came up as the best potential match. And already the naked eye, you've got a lot of similarities here with the within the shear marks, also the striations on the surface. You can see with the ring light image that we're looking at, there's some common details between the two. So what we're going to look at now is the correlation results for the bullet score. So what we want to do now is see how much common information there is between these two exhibits by sliding them together and also by moving that hairline back and forth. So what the Tracks machines are enabling firearms examiners to do now in the crime lab is to scan through thousands of reference exhibits now, cross jurisdiction as well, that are just numbers that would never be possible, and it's really given them new tools to create links in crimes and get criminals off the street.